Hello. In this discussion, we're going to begin to talk about parts room assemblies. This unit is really about Quartz 2D graphics and how we're going to use that within the parts room application. But before we can really talk about making an assembly from catalog parts, we have to back up and talk about, sorry about that, let's go back one. We have to go back and talk about a little bit about relational data in database and really what a relation is in a database. So SQLite is an RDBMS. It's a relational database management system. So the question that should come to mind, especially if you have never worked with SQL, is what is a relationship anyway? Well, relationships exist between keys, which are fields in tables. Furthermore, relationships exist between particular rows in different tables. There are three kinds of relationships, and these three kinds are usually called one-to-one, one-to-many, and many-to-many. So here are some examples. A one-to-one relationship is when an entity, which is a row in a table, is only associated with exactly one other entity, a row in a different table. So some examples here. A book can have only one title, and a single title refers to one book, let's say in a perfect world. An iPhone has only one phone number associated with it, and that phone number uniquely identifies that iPhone. That's just a couple of real-world examples that we might use to point to what a one-to-one relationship is. One-to-one relationships are fairly common in databases, but usually the most common relationship we see in a database is a one-to-many relationship. Now this is used when one row in one table refers to multiple rows in another table. So a couple examples again. A family can have multiple mailing addresses, but each address refers only to a single family. So this is a one-to-many relationship. There is one family being talked about, but there are many addresses being talked about. Another one is a postal code. Contains many addresses, but each address is only in one postal code. Now, someone may come along administratively and change the boundaries of postal codes, but at any given point in time, each address is only located within one postal code. So these are one-to-many relationships, and overwhelmingly, most of the relationships within database tables or between database tables are one-to-many, and they are the simplest to set up. Now, one-to-one and one-to-many relationships each require two tables, one for each side. So there is a entity in table A and an entity in table B, and they can be in either a one-to-one or one-to-many relationship. So in the simplest case, the constraint is put on the data by the developer of the database. But an RDBMS can be used to manage the constraints as well. In other words, we can set up entity relationships within SQLite, let's say, or MySQL or MS SQL, and so forth, and allow the database to manage the constraints that tie into what we call referential integrity. In other words, the integrity of the relationships and their references between tables. We're not going to do this here because this is not a course about SQLite. It's a course about iPhone development. So I just want to show you, though, that if we were going to do this, think about a one-to-one relationship is really a relationship between two tables that have two primary keys, one for each table, and two foreign keys. When we have a primary key, foreign key relationship, a single relationship is always one-to-many. So to constrain a relationship to one-to-one, we need to have such a primary key, foreign key relationship from each table. So that's what I've indicated here. One primary key in this table refers to many foreign keys in this table. One primary key in this table refers to many foreign keys in this table. So this constrains our relationship to one-to-one. And one-to-many, we only need one relationship. One primary key in the first table refers to many foreign keys in the second table. And when I say a key refers to a key, what I'm really saying is one row, one entity having a key in the first table refers to many rows or entities in the second table, each of which have the same foreign key. A primary key is unique within its table. A foreign key is not. Now, many-to-many is different. Many-to-many relationships require 3 tables, because we know that our relationships so far, what I've told you, is that our relationships are always one-to-many. Well, in order to get a many-to-many relationship, we need to have, and I got one of my relationships backwards. That's okay. I'll explain that in a moment. We need to have 3 tables. We need 2 tables, one for each entity in the relationship, and a third table to contain one foreign key that points back to the primary key for each table. So this side is right. The right-hand side is right. We have one key in this table, one entity, row, whatever we want to call it, in this table that corresponds to many rows in this table. And all this table really usually contains is foreign keys for each table in our relationship. So this foreign key, there can be many combinations of many keys from each table. So we have one over here, we have many here. We have one over here, and we have many here. And in this way, we can associate many entities from one table with many entities from another table. So this relationship, the one should be here, and the many or infinite symbol should be over here. So why all the theory? What's the big deal? Why are we talking about this? It's interesting, but is it only interesting, or does it pertain to what we're actually doing? Well, when we start to talk about assemblies in our PartsRoom application, these are assemblies of parts that are in the parts catalog. One part can be in many assemblies, we know that, and each assembly, because of its very nature, will contain many different parts. So this is a many-to-many relationship. So we're going to need a join table. In other words, we're going to need a table containing only foreign keys between the assembly table and the parts table. So by having such a join table, or the catalog table, by having such a join table that contains the keys of the part and the assembly, we can model this behavior in the database rather than in code. And this is very good, because if we have to model in code, it's going to take more coding. But if we can just set it up one time in the database, that's better. So we got a couple examples of join queries that we can look at. One, and join queries tend to be of 2 parts. Now, we can fold all these things into one big query, but it's better to get the ID of one table and then put it into a join query in another query to get something out of the second table that we want. So the first set of queries here is to find all assemblies which contain a particular part. So in the first query, we're getting the ID from the part table, from the catalog, where the part number equals the particular part number that we're looking for. We need the ID because the ID is going to be the foreign key in the join table that we're looking for. So we select the name and and here what we're looking for is quantity of parts within an assembly. We select the name and the quantity from the join table, from the assemblies interjoined with the join table, where the join table part ID equals the ID. And this will actually give us the quantity of a particular part within any assembly that contains that part. The second query here is find each part used in an assembly. We select ID from assembly, where the assembly number is equal to something that we're looking for. And then we select the name. We're looking for the part's name from the catalog, interjoined on the join table, where the assembly ID is equal to the ID that we got back from the first query. What this will do is it will give us each part's name in a particular assembly. Now, as we work with these queries, and as you work with the queries for yourself, you're going to streamline some of these, but it gets easier as you work with this. And if you have never worked with SQL, I'm probably speaking a foreign language right now, and I understand that. So what you would need to do to really get acquainted with SQL, and particularly SQLite, is go on their website and read the documentation, read some good standard generic documentation on structured query language, and we'll go from here. I've already set up the database for the demos, so don't worry about the guts of the database. We'll just see these query types, and I wanted you to be acquainted with them with a little bit of theory before we went ahead and started in on the demos. Thank you very much.